Alright, so we are going to start chapter 3, which focuses on parallel and perpendicular lines. So some of this will be review from Algebra 1, and some of this will be new, because we'll learn some different postulates and theorems and properties that apply to parallel and perpendicular lines. So first, we need to look at a couple of key definitions. So we know what parallel lines are, but more specifically, we want to remember that they are coplanar. They're coplanar lines that do not intersect. They have to fall in the same plane. Then skew lines do not intersect and are not coplanar. So they have to be on totally separate planes. They can't be on the same plane if they're skew. That's like a line going across the ceiling in my classroom and the floor of my classroom, and they're never going to intersect each other. Parallel planes are planes that don't intersect. So that's like the ceiling in my classroom and the floor of my classroom. It's never going to intersect, they're parallel. And then a transversal is a line that intersects two or more coplanar lines at two different points. So in this picture, we have three lines, K, H, and J. And line K is actually the transversal. And we don't know if H and J are parallel or anything. We just know they're two lines that are intersecting line K at these two different points. So what I want you to do, you can pause this for a second if you want to, but I want you to work out 13 through 20 that are right here in your notes. Do that you can with those. We will go over them in class, but I want you to try to get those on your own, and we will discuss them. Alright, so we have all these different types of angles that we have to be able to identify when we're working with transversals. So if we look at this picture, if you can tell, line T is intersecting line A and line B, so T is the transversal. And I'm apologizing now for my handwriting. I'm writing on my laptop, and I've got to adjust to how this is going to be. I'll get better, I promise. So if we look at this picture, the interior is considered to be what's in between A and B. So this is the interior. The exterior is up here and up here. Or sorry, down here. So that's the exterior. So when I'm talking about the interior angles, that's going to include angle 4, angle 5, angle 3, and angle 6. And then the exterior angles would be 1, 2, 8, and 7. And so you've got to be able to identify these because they're all going to have specific properties, which we're going to talk about. So if I'm talking about consecutive interior angles, those are going to be two angles that are inside, so they're considered to be in the interior, but they are on the same side of the transversal. So 4 and 5 are consecutive interior. These are pairs. And then 3 and 6 are consecutive interior angles. So all of these from angle 3 to angle 7, those are pairs, from number 3 to number 7, those are pairs of angles. So consecutive exterior means they're on the exterior part of the two lines, but they are on the same side of the transversal. So angle 2 and angle 7 would be one pair of consecutive exterior angles. And then angle 1 and angle 8 would be the other pair. Alright, then the alternate interior angles, they have to be in the interior of the two lines, but they are on alternate sides of the transversal. So angle 4 and angle 6 are one pair, and then angle 3 and 5 make up the other pair. So alternate exterior angles are on the exterior of the two lines that are not the transversal, and they are on opposite sides. So angle 1 and angle 7, that is one pair. And then angle 8 and angle 2 makes up another pair. Okay, last we have corresponding angles. So corresponding angles are angles that are on the same side of the transversal, but they're in the same position in reference to the line. So for example, angle 2 is on the right side of the transversal, but it's above line A. So angle 6 is also on the right side, and it's above line B, so 2 and 6 are corresponding. So then we also have angle 3 and angle 7. They're not necessarily congruent. Let me erase that so I'm not confusing anyone. I just want to mark them differently. Angle 3 and angle 7 are both on the same side of the transversal, and they are both underneath the two lines. So those are a pair of corresponding angles. And so then on the left side, we've got angle 1 and angle 5. And then we have angle 4 and angle 8. So look at all those angle pairs and make sure you can recognize them, because you're going to have to know these to understand a lot of the theorems and postulates we're going to discuss. So when we have a transversal, so here R is the transversal, and we know P and Q are parallel. So when that happens, that makes things work out a lot better for us, because we can find a lot of different angle measures. So what angles do we know are congruent to angle 6? Well, you know angle 4 is congruent to angle 6, so it's also 75 degrees. And that would be by the vertical angle theorem, because vertical angles are congruent. Well, then you should be able to find the measure of angle 5, because what do we know about 4 and 5, those two angles, if we add them together? You know they're supplementary because they form a linear pair. That's by the supplement theorem. So 180 minus 75 leaves us with 105. So this angle here is 105 degrees. Well, one thing that we know is that corresponding angles are congruent, and we'll talk some more about that. But if corresponding angles are congruent, remember those are the angles that are on the same side of the transversal in the same position either above or below the other lines. So like angle 6 is congruent to angle 8. So if 6 is 75, angle 8 is 75. If angle 8 is 75, then angle 2 is 75 degrees, of course. And then angle 3 and angle 5 are a pair of corresponding angles, so they are each 105 degrees, and this is 105 degrees. And we know that because angle 1 and angle 2 are supplementary because they form a linear pair. So there's lots of ways you could prove this. So if I give you one angle measure, in a diagram like this where I have a transversal that intersects two parallel lines, you should be able to find all of the other angle measures just based on supplement theorem, based on the vertical angle theorem, and then knowing that corresponding angles are congruent. So if we look at that, one more thing, we need to go back and think, all right, which angles were congruent? So what congruent angle pairs? So we know that angle 4 and angle 6, we know angle 6 and angle 8, we know angle 6 and angle 2, we know angle 2 and 8, and we know angle 8 and 4. Do we leave any off? 4 and 8, I think that might be all of them. And then we know that the angles that are supplementary are all of the ones that form linear pairs. There are a lot of pairs that are supplementary, so make sure you recognize those relationships between those angles. So we have this corresponding angles postulate. So that's what I was just talking about. We know that the corresponding angles are congruent. So we have this postulate. So corresponding angles are congruent. Got to know that. Remember the difference between postulates and theorems. Postulates are accepted as true. Theorems we have to be able to prove, or they can be proven. So alternate interior angles theorem. Remember we said in the slide before, these two angles were congruent. So two parallel lines are cut by a transversal. That has to happen first. So we have to have two parallel lines cut by a transversal. This doesn't work if the lines aren't parallel. then each pair of alternate interior angles is congruent. Same thing for corresponding angles. We have to have two parallel lines cut by a transversal. Otherwise, none of this works. Then we have the consecutive interior angles theorems. Remember, those are on the same side of the transversal, but they're both inside the two lines that the transversal intersects with. So if we have the two lines that are parallel, then each pair of alternate interior angles is congruent. I'd already told you that, sorry. Then each pair of consecutive interior angles is supplementary. So if I look at 4 and 3, those two we know aren't congruent. We know that 3 and 1 are congruent. So if 1 and 4 are supplementary and 1 and 3 are congruent, then that tells us that 3 and 4 are supplementary. That's actually by the converse of the congruent supplement theorem, and we'll work on proving some of that. All right, alternate exterior angles theorem. So if two lines, parallel lines are cut by transversal, then each pair of alternate exterior angles are congruent, which we showed how that works in the slide before. And then the perpendicular transversal theorem. In a plane, if a line is perpendicular to one of two parallel lines, so we've got this transversal T, and it's perpendicular to line A, then we know it has to be perpendicular to B if A and B are parallel. We're going to actually end up proving that later on too. Take a look at those. If you have questions about them, we can discuss them. All right, so we're going to find X for this first example. So we know that angle 4's measure is 2x minus 7. And remember those purple lines that are on the two lines tell us that they are parallel. So we have a transversal that is cutting or intersecting two parallel lines. All right, angle 1 is 85. So we've got to figure out what X is. Well, is there a relationship between angle 4, one of our special angle pairs? They're not alternate interior, alternate exterior, corresponding, none of that. But what do we know about angle 4 and angle 2? Well, you should recognize they're corresponding, and we know that corresponding angles are congruent at the corresponding angles postulate, so this is also 2x minus 7. Well, then we know that angle 1 plus angle 2 should add to be 180 by the supplement theorem. So we're going to have 85 plus 2x minus 7 equals 180, and I want you to solve for x. So then in example 2, I'm going to leave that first one for you to finish. You should be able to do that. So in the second example, we know that at the measure of angle 3 is 4y plus 30. And we know the measure of angle 7 is 7y plus 6. So you got to think, what's the relationship between angle 3 and angle 7? Well, you should recognize that they're alternate interior angles. And by the alternate interior angles theorem, we know that they are congruent. So we can take 7y plus 6 and set it equal to 4y plus 30 and solve. So I'm going to leave that for you to solve as well. All right, so we have to find x in this picture, and this is different than the others that we've worked with. So we know this angle up here is 65. We know this is 136, and then we're looking for x. So the way we're going to do this is use an auxiliary line. So we're going to draw an auxiliary line right through that angle. It should actually be exactly through the point of intersection of those two rays. So it's kind of hard for me to get it exact, but you should be able to draw one. And another thing we need to know that we should be given, and I'm going to add this just so we know, is these two lines have to be parallel. If they aren't parallel, all of this is not possible. So we draw in this auxiliary line so that it is parallel to these other two lines. So technically what we're working with here are two different transversals. So what you basically want to do is just look at the bottom half of this graph, or this picture. So if I look at the bottom half, if this is 136 degrees, what's the measure of this angle? So we take 180 minus 136 and we get 44 degrees. Well, then we know by vertical angle theorem, this is 44 degrees. And then we know this is 136 degrees for the same reason. Well, if I'm just comparing this line and this line, don't even worry about anything up here. Forget about all that for a second. What's the relationship between this angle and this angle? Or what's the relationship between this angle and just this part of this angle? Well, if you look, they're both in the interior between these two parallel lines, and they're on opposite sides of this transversal that's going through right here. So they are alternate interior angles, which we know are congruent. So if this angle here is 44 degrees, we know this is 44 degrees. And so there's nothing else we can really do with that, so we're going to stop for a second. So then up here, by the same reasons, if this is 65 degrees, this angle is 65 degrees by the vertical angle theorem. And then we know these two are supplementary by the supplement theorem. So if we take 180 and subtract 65, we're going to get 115. So this angle here is 115 degrees. So is this one by the vertical angle theorem. So then forget about the bottom now, and I can actually cover it up for us. So if I forget about the bottom, I'm just looking at the top. We've got these two angles, this angle here and this angle here. So think about these two lines as the parallel lines, and then this here is the transversal. So the relationship between this angle here and this angle here is that they're alternate interior angles, and we know by the alternate interior angles theorem that they are congruent, so this is also 65 degrees. Okay, so if I want to find x, we know x is going to be 65 plus 44, which makes 109 degrees. So the measuring angle x is 109 degrees. So go back and look at that. If you need to rewatch it, you can, and bring your questions into class and we can talk about it more if we need to. All right, prove the alternate interior angles theorem. So I want you to take a look at this. I want you to, obviously you should know what we write first. Think about how we would prove this, and we're going to go over this in class. Think about how you would prove this. Shouldn't honestly be that difficult. You know enough information, and I know y'all are smart enough and capable enough and can figure it out. But we'll go over it together in class to make sure we're all on the same page. So for the wrap up, I want you to answer these questions and figure out this angle. And let's say that this angle here is 38 degrees. That's 38 degrees. So find all the other angles. So work out the wrap-ups, work on the proof, and then the two equations and the problems from the notes, and bring this all to class, and we will go over it. I will see you then.